Hi class, I want to do a video this week on partial fractions or partial fraction decomposition. And I don't really want to spend too much time actually talking about integration so much as an algebra method to take really hard integrals and make them easy. So the videos and even the other optional videos and supplemental videos don't really talk too much about integration actually, more as just this algebra method. Alright. So the method of partial fraction is a procedure for decomposing a rational function, so like take this one right here, 1 over x squared minus 5x plus 6, into simpler rational functions, okay? And once they're into simpler ones, you can apply the basic rules, alright, to integrate them. Alright, to see the benefit of this method, consider this integral. Now, if I were to just give this to you right now and say find the integral, you actually, there's no rule for it. You couldn't do it. Like, you can't do it. What I'm saying is you can't evaluate this integral as it is written. So you need a procedure to find it. Okay, or a procedure to rewrite it. All right, so here's what we're going to do. Suppose that you had observed that this right here, now I notice that you know that these are the factors that it factors into, but that this fraction right here is the same thing as 1 divided by x minus 3 minus 1 over x minus 2. Like if you were to recombine these like with a common denominator, you would get back to this. So then what you could do is you could evaluate this integral very, very easily. This, our original integral as it written we couldn't solve, is just equal to this one right here. Well, this and this integrates super, super easily as just the natural log of the absolute value of each of these things that's down here. Alright, so this method is clearly preferable to trigonometric substitution, which is another way you could do this, but it's incredibly hard. Alright, so however its use depends on the ability to factor this denominator and then to find its partial fraction decomposition. So meaning that this original fraction up here can be written as this minus this. Alright, so we need a procedure to do that. Alright, so even before we do that, we've got to talk about factoring. So recall from algebra that every polynomial with real coefficients can be factored into linear and irreducible quadratic factors. Like for instance, if you take this, x to the 5th plus x to the 4th minus x minus 1, you can rewrite this simply by factor as grouping like this. This becomes the difference of two squares, and so on and so on. Like this right here is an irreducible quadratic factor, and this are linear terms. Okay, so this, and irreducible quadratic. So linear, irreducible quadratic. Alright, so where x minus 1 is a linear factor, x plus 2 is a repeatable linear factor, and x squared plus 1 is that irreducible quadratic factor I was talking about. Alright, so using this factorization, you can write the partial fraction decomposition of this. Alright, so notice it was just this, now we're just putting it over something. Alright, where n of x is a polynomial of degree less than 5, because our original one here is 5, so the top has to be less than 5. Okay. So what we have to do then is we could break this up as whatever this is equal to the first linear factor, one factor of the repeatable linear, then the second repeatable linear term, then divided plus a fourth one here where it's the irreducible quadratic factor. But here a, b, and c are just constants. Okay, like it could be 5 or 4 or 1. And this right here, notice how there was a squared here, and over here I put in x. So like here the degree is 1, so the numerator is degree 0. Here the degree is 2. Up here the degree is 1. So I write this as dx plus e. Okay, so decomposition of partial fractions. Alright, so first off, when it's an improper fraction, so that is something like a 5th power divided by a 4th power. Or 4th degree, excuse me. You could just divide. Just use the dividing algorithm here to quickly divide, and then it should be pretty easy. Alright, if that doesn't work, what you would then do is you would factor the denominator completely. So like here, we took this and we factored it completely. Alright, into factors of the form like this, and then like this. And this is where this you can't reduce. Alright, for each factors of this form, alright, so px plus q, like this, or like this, okay, that's px plus q. You would write it as a1 plus a2, however many there were. Like you see how they're squared. I wrote 1 and then 2 here. Like here it was x plus 1 squared, so there was one of them, and then it was x plus 1 squared. All right, for quadratic factors, for each one like this, you write it and then bx plus c. So like this one right here, x squared plus 1, dx plus e. And then what our job now is we have to find out what the values of a1, a2, am, b1, c1, all those values are. So it's a little bit tricky at first, and it's going to take a while, like watching my video and then the other videos I post, to kind of get the process down. All right, so let's do a really, really simple one of just linear factors. All right, so write the partial fraction decomposition of this. So how we found this. All right, so the first thing we're going to do is factor it like this. You should include one partial fraction for each fraction and write, or each factor, and write it like this. So 1 divided by x squared minus 5x plus 6. Well, our factors were x minus 3 and x minus 2. And I'm going to put them over a and b. The thing is, I don't know what a and b are. I have to determine them. Okay, I have to determine them. All right, so multiplying this equation by the least common denominator, it yields the following. All right, this is our least common denominator, x squared minus 5x plus 6, which is just this. So this, when I multiply by the least common denominator, cancels out, you're left with 1. So 1 is equal to a times x minus 2 plus b times x minus 3, because that's the factor it's missing. So now I have this simple equation here. 1 is equal to a times x minus 2 plus b times x minus 3. And what I have to do is I have to use this equation to solve for a and b. Now what's weird is you'll notice there are 3 variables in here. There's a, there's b, and there's the x values. Okay, so what you're going to do is you're going to actually end up picking x values to help you find a and b. And you want to pick x values so that one of the terms will go away. Like for example, if I pick x is equal to 2, well, I get 2 minus 2 is 0. It goes away. All right. Because the equation is to be true for all x, you can substitute any convenient values for x to obtain into the equations and to find this a and b. All right. The most convenient values are ones that make the particular factors equal to 0. Like if I pick x is equal to 2 or x is equal to 3. So for the first one, to solve for a, I'm going to let x equal 3, because when I plug 3 into the other value here, 3 minus 3 is 0, the b goes away. So when I simplify like that, it's very easy to see that a is equal to 1. All right, once you know that, you can solve for b. So you want to get rid of the a term. So if you look back here, if I plug 2 in for x, the a goes away because I get 2 minus 2 is 0. 0 times a is 0. So doing the same thing, plugging in 2 here gets rid of the a. You can see exactly how this happens, and b is equal to negative 1. So our decomposition here, this a, which was 1, over x minus 3, plus b, which is minus 1, so I just moved the minus in front, 1 over x minus 2, which is what we saw at the beginning. All right, so the whole idea here, this is the easiest case. You just write it as the factors plus a and b here. Then you get the least common denominator, multiply through, and then you pick x values to plug into here differently so that the first term goes away and then the second term goes away. All right. I encourage you to definitely print this out and review it as well as you go through these problems. All right, let's do a really hard one. All right, of quadratic factors, okay? So let's find this one. All right, so let's integrate, whoa, this crazy thing right here. So 2x cubed minus 4x minus 8 over x squared minus x times x squared plus 4. Okay, first off, this is an irreducible quadratic factor, so I can't simplify that. But here I notice I could factor out an x. All right, so that's the first thing I'm going to do. So now I have 3 terms. I have x times x minus 1 times x squared plus 4. All right, so you should include one partial fraction for each factor and write this. So this is my original one over a over x, b over x minus 1 because it's a linear. And because this is a quadratic, x squared plus 4, I'd write it over cx plus d. So now here's the thing. I need to find the values of A, B, C, and D. All right, this right here is my least common denominator. So what I'm going to do is I'm going to multiply everything by the LCD. All right, and when you do, the LCD here cancels, and you're just left with the top of the equation. And then A, it's missing, it has an x, so it's missing an x minus 1 and an x squared plus 4. Plus B, it already has an x minus 1, so it's missing an x squared plus 4. And then Cx plus D, it already has an x squared plus 4, so it's just missing an x minus 1. All right, without looking at this, I think I know immediately which value I'm going to solve for. All right, I'm going to try to find the value A. And I'm going to do so by letting x equal 0, because if I plug 0 in here, it wipes that out. If I plug 0 in here, it wipes that out. Okay, so when we do that, we plug in and simplify, we get very easily A is equal to 2. All right, so now going back. Here, if you let x is equal to 1, it'll cancel this out, and it'll make this go to 0, and you can very easily solve for B. All right? So solve for B, let x equal 1, and you obtain this. B is equal to negative 2. So far, incredibly easy. We have A, and we have B. Now we just need to find C and D. All right? Now if you look back here, it's a little bit complicated because I can't really plug anything in to just have this and this drop out while keeping this. So we're going to need to do something a little different. All right? So at this point, C and D are yet to be determined. You can find these remaining constants by choosing two other values for x and solving the resulting system of linear equations. Watch. All right, using x is equal to negative 1, then A is equal to 2, and B is equal to negative 2. So I just picked x is equal to negative 1 just because. All right, and I'm going to literally plug it into this crazy formula here. So what A and B was, 2 and negative 2, and then I'm going to replace x with negative 1. And I'm just going to go right through the equation. And when I do, I get this, which simplifies very easily. You can go through the algebra yourself into this. All right, so I have one equation, two unknowns, so I need to do it again. So I'll just choose a different x value. I'll just pick x is equal to 2, whatever. I'll plug it into the equation, and this is what I get. Simplifying, I get that. All right, so now look what I have. I have one equation up here, another equation up here, so I have two equations and two unknowns. So how you solve that is just very simply with systems of linear equations. So solving the systems of the linear systems by subtracting the first equation from the second, it just really very easily yields C is equal to 2. And then you can do the same thing and get D is equal to 4. Once that happens, this can immediately factor into 2 over x, that's the A, minus the B. This is my C plus my D right here. Boom, boom. Easy to integrate very, very quickly. Just like that. So the hard part there wasn't the integral because these are very obvious to do. The hard part is all this algebra that I'm just going back through. All this algebra right here is the hardest part of this problem. Okay. Just one last thing, the guidelines here. Okay, so some guidelines for solving these. All right, linear factors, substitute the roots of the distinct linear factors into the basic equation. For repeated linear factors, use the coefficients to determine the first guideline to write the basic equation, then substitute other convenience for x to solve for the remaining coefficients. Quadratic factors, expand the basic equation, collect all terms according to powers of x. Equate the coefficients of like powers, obtains the systems of linear equations, solving for A, B, C, and so on, and then solve that system. So it's not easy stuff, the two examples that I've done. But I encourage you to go and watch all the other supplemental videos and give it a shot. Thanks, guys.